Hi, this presentation will be about the future of wearable technology. That means things such as Apple Watches and any other smart device that is an accessory to a smartphone. In 2016, there were 325 million active smartwatches fitness trackers worldwide. That number has obviously skyrocketed from zero when they didn't even exist a couple years ago. But by 2020, that number is projected to triple. And each of these kind of devices has, heart rate monitors, accelerometers, GPS, and it varies from device to device. But I guess the two most popular ones being the Apple Watch and the Fitbit, you can kind of, you know, say, okay, they all share these common threads. But as the number of users is increasing, the amount of data that's generated is also increasing. So if ideally to the companies, if someone is wearing one of these things all the time, they're constantly dating or generating data, whether they're awake or sleeping or running or whatever. And this is great because users can track things like their sleep cycles and a bunch of stuff that would be difficult to gather data on in any other way. But ethical questions do come up regarding what do the companies do with that data after the fact, because people are, when they buy these things and they put them on, they're forfeiting their biomedical data to whoever the manufacturer is. So wearable tech is important to study. You could say just because there's already hundreds of millions of people using it. And this is something that's happening on a wide scale all across the world. I mean, mainly in America and kind of Asian countries, that's where the largest percentage of these things are. But the projected growth is worldwide. And so they link, and as they've gotten better, because before, when they first started to come out, there were heart rate monitors, but the accuracy wasn't great, and there wasn't as much variety of sensors. But as technology improves, you're going to get more accurate ones, and they're going to have a smaller footprint and probably lower cost as well, which would encourage more and more people to use it. So for that reason, it's important to study this technology. One of the main sensors that they all share is a heart rate monitor. And how this works is just an optical, it's an LED photodiode pair. This is something we actually made in another class that I took here at Oregon Tech. So it's not something that's above student level of understanding, but it's just, it has an LED that is shown into your skin, and as your blood vessels expand and contract, certain wavelengths are reflected or absorbed. And then this is detected by a photodiode or a light-dependent resistor, and that transmutes the signal of your pulse into an electrical impulse, and then there's onboard circuitry to amplify and isolate the signal. Accelerometers are another pretty key thing to have in there, but they essentially just gather position data in 3D space and relative movement pretty precisely. And the Fitbit Surge and Apple Watch use 3-axis positioning. So you have 3 axes, X, Y, Z for 3D space. But this can be used for a number of things, mainly I believe for the pedometer and just other measurements of relative movement. But below we have the block diagram of how it works in a basic way. GPS, most of these devices don't have GPS on board, but because they're, to keep costs low, they are paired with smartphones just inherently. That's where they're sending the data. They're sending the data to smart devices which do have Bluetooth. So they can use that kind of piggyback onto the GPS of smartphones. Most of them don't have dedicated GPS, but basically, GPS I guess is common at this point, but you have satellites that are triangulating and confirming the position of the person on the ground. And you can measure relative distance at this point in time very accurately, and relative position. So, but that's good for fitness purposes, how long did I hike today, that kind of thing. Altimeter It has pressure-based sensors which transduce barometric pressure into electrical impulses. So this is, I guess, could be used to supplement GPS data, or if you say you go on a run and you don't bring your phone with you, so you don't have GPS, you could still know, if you're doing a big climb, hike, or something, you still know how much distance you traveled vertically. But it has a lot of other applications as well, so it just tracks altitude, fitness, scientific stuff, aeronautic stuff. And yeah, there's just a little block diagram down there of generally how it works. But I feel like with any of these transducers, it's kind of the same thing of small, noisy-ish electrical impulses created, and then there's some filtering and amplification that takes place, and then that's output serially back to the device for processing. So the question is raised when you say, okay, we have all these sensors and we can gather this data. What's done with the data once it's been tracked by the thing? Because there's fragmentation in the market and just a ton of different devices out there, there's not really uniformity between how it's done company to company, but you could say that the data follows a general path, which is that sensors in the watch or the wristband or whatever, they measure the data locally with the sensors, do some processing on it, and maybe can output some stuff locally if your device has a display, but then that is transmitted via Bluetooth serially to the smartphone of the user, which has, there's some application that's usually tied with it, whether it's like Samsung's has like S Health, or there's Apple Health, or any of these other, they're used for tracking it, but then it's stored locally, and you can see your trends over time and all this kind of stuff. And then ultimately that data is given, stored by the manufacturer in their proprietary servers. And the way that it's segmented is actually they can, there's differences between how this works generally, but there's like class types that determine just automatically based on the content of the data can determine if it's a sleep state, an awake state, or an active state, and then mark it accordingly. But the thing is when you're collecting all this data, there's just a bunch of like metadata about the data generated in accordance with it, and also the combination of combining all the sensors together. That alone, you can interpret things based on that. There is potential for third parties to have access to users' biometric data. Say that a company in their end user agreement says, that by using the whatever watch, the user is forfeiting their right, and the company is able to then sell this data to third parties. You would have, advertisers, insurance companies, the manufacturers themselves. These are all people who say, okay, we want to do something with this data. We can interpret trends, we can mark, just trends over time and compare them with other trends over time based on data that we already have. And that's just something in the smartphone era, I guess, that is very prevalent, is figuring out how people are generating all this data. How do we interpret what it is and what it means? But the question there is, what do consumers think they are consenting to versus what they're actually consenting to? I don't know if on a case-to-case basis, if what people think is being done with the data, if it's just being discarded after a certain period of time, but I'm under the impression that it is stored, in my research I found that it is stored most of the time by the companies in their proprietary servers, and potentially can be sold to advertisers and whoever else. So the collated sensor data, meaning just all of the measurements at once. So at one point in time, you have access to multiple measurements. This can be used to generate trends or just measure trends over time, because really any set of data over time, you can create big graphs of it. These trends, people are simultaneously with their watches are generating other trends as well. So like their browsing history, their phone behavior, their location. And so if I was an advertising company, I would say, all right, I know when people are looking at web pages, for example, that they're seeing ads on. Like, you could literally compare their biomedical response to when they see an ad in the, okay, how does that affect the frequency of that? This kind of thing. So but the users themselves don't necessarily know that this is happening, or if it is happening at all. So I believe that it's the ethical responsibility of companies to protect their users' data, or at least make it very clear that when they, put one of these kind of devices on, that they are in fact submitting their data potentially to third parties who will use it to try and sell them things, or sell insurance, anything else, that kind of stuff. But in conclusion, wearable tech is a market which is expanding greatly. It's gone from zero to through hundreds of millions already, and surely will grow exponentially in coming years. So it's something that's worth measuring and studying. And these devices, they combine sensors and processing software and smartphone apps to record users' progress, which is great for people, trying to track their progress in fitness or hiking or losing weight, any of these kind of things. A lot of companies do step challenges and whatnot. So there's a lot of potential for good here, but also I just think that what's done with the data can be a point of concern, and the people manufacturing the devices and gathering the data, the responsibility is on them to make sure that it is handled safely and in the customer's best interest.